In this example, we can see a spring and mass system. The object is oscillating, and you can see when it's stretched the most, it's got lots of elastic potential energy, and then it turns into kinetic energy, and then that turns back into elastic potential energy when the spring is compressed. So when it's at its amplitude, the bigger maximum displacement, it's stored the most potential energy because it's either stretched a lot or it's compressed a lot. While when it's in the center, it's going the fastest in either direction, and it's got most maximum kinetic energy in the center. The total energy stays constant because there's no resistive forces, so none of the energy is being wasted as thermal energy. So what we have in this diagram here, we can see when it is maximum here, we've got largest potential energy over here and here because the spring is stretched. And if it was a pendulum, it's because it would be gravitational potential energy, and it would be because when it's furthest away from the equilibrium, that's when it's at its highest. While in the center, we can see all of the energy is kinetic energy because it's going the fastest, and it's at its low, like it's not, the spring isn't stretched at all or compressed, and the pendulum is at its minimum height. The top line represents the total energy, which is the sum of the kinetic energy and the potential energy. So for example, at this point, if I added the potential energy here and here, I will get the total energy over here. If there was resistance in this, resistive forces in this diagram, then the total energy will decrease, so the bar would come down. That's because a lot of the energy is being turned into thermal energy. Of course, energy is still conserved, it's just it's being turned into thermal energy. So the shapes of the kinetic energy, potential energy, quadratics, the straight up quadratic and the inverted quadratic will just be below the total energy line. We can figure out the total kinetic energy by thinking about the maximum kinetic energy over here. So the maximum kinetic energy, if you remember from the last equation, V max for simple harmonic motion is omega times A. So the maximum kinetic energy will equal half times mass times V max squared, which is omega A squared. Now this, of course, is going to equal the total energy, because at this point here, all the kinetic energy is the total energy. So it's half m omega A squared.